Okay guys, let's start it. Let's see what we have. Okay. What happened to this? Let me restart it. Where's my... No, my VPN is off, so... Rotating the box, okay. So what's given? You're given a matrix of characters representing a side view of each cell. Each cell of the box is one of the following: a stone, a stationary obstacle, or empty. Box is rotated 90-degree clockwise, causing some of the stones to fall down due to gravity. Each stone falls down until it lands on an obstacle, another stone, or bottom of the box. Inertia from the box does not affect the stone's horizontal positions. Okay. It is guaranteed that each stone in box grid results on an obstacle, another stone, or a bottom of the return. So essentially what's happening, I think this might be a DP array, DP problem, but let's... So if I have a matrix, there is some stones here, or an obstacle. When I rotate it by 90 degrees clockwise, right, the bottom stays as is. This will shift down and this will be empty, right? So the phone starts to fall down due to gravity. So basically what's happening, if it's... So what I'm thinking is, let's say I take a row, I take each row by as is, and okay, it is guaranteed that each stone in box grid rests on an obstacle. Okay, representing the box after rotation. So obstacle does not, it is guaranteed. Okay, obstacle position is fixed, right? Okay, so if I have obstacles here, okay, so should I take each row? First thing is take each row and modify it, move the elements, right? If obstacle is present, and then, right, okay, the box relation. Okay, so the hints they've given is, first we rotate the box, okay, or we rotate the box remains as is, and then check if there is stuff. Okay, this is the hint that's given. So let's is it teacher r equals to box grid, sorry, box grid dot length, right? And integer n equals to box grid 0 dot length. Okay, and how will we rotate? So when our rotation will work, 1 second. So if I have, let's say if I have a 2x2 matrix called A, B, C, and D, if I have to rotate it, it becomes what? Like this, right? C is here, D is here, A and B. So R ij is what? 0, 0 becomes 0, 1, right? And number of rows is 2, because we are going ij becomes j comma m minus 1 minus I. That's the relation it's given, right? So for example, this is 1, 0, so 1, 0 becomes 0 comma 2 minus 1, 2 minus 1 minus I, 0 comma 0. So R C becomes 0, 0. Let me check about D. DF, D is 1 comma 1, right? So that is 1 comma that is 1 comma 0. Okay, so integer equals to 0, I must be less than m, right? I plus plus, and for integer j equals to 0, j must be less than, and j plus plus. We save, but here, so we have a character temp is equal to grid bracket I and j, right? Grid bracket I and j is equal to grid bracket j and m minus I minus 1, and grid bracket hint is given. Our relation is m minus 1 minus j. What? Did we have it wrong? Okay, let's do it again. 0, 0, 0, 1, 1, 0, and 1, 1. Rotated 90 degrees, right? We have S goes this, so we have 1, 0 here, 1, 1, 0, 0, and 0, 1, right? So formula is 0, 0 changes to what box of bracket m is 2 minus 1 minus j 0 and bracket I 0, so that is 0 0 changes to 1 0. Let me take 1 1 is 2 minus 1 minus 1 0 1 and 1, sorry, 1 1 goes to 0 1. Okay, so this is m minus j minus I and bracket I and do I associate a visited thing? Because if I do this grid minus j minus I bracket I equals to temp, right? End of loop. Thing resets, right? Because for first iteration I change it. When I go back to that place, so it should be when j is equal to I plus 1 or I. I only want to do it until half, right? So let's see if I'm doing it correct, but I think the loop might be wrong. Don't answer the question yet. See, I think the loop will make it matrix back to chain. Oh, I see. Okay, so I need to create a rotated character array. Rotated equals to new character. Right. So I'll just do, so I could just do rotated array of j equals to box grid of m minus 1 minus j and I. Okay. J and instead of J. Okay. So now, so take each column separate and then use right. Okay, so now I think now we take each column, right? Okay, right. So now I have the matrix, right? So so matrix of M and N, right? So okay. Sorry. Okay, what's given is, so we have stuff here, right? So I have to take this row. So usually what we do is for integer array row in something that will take this, right? So what if I do for how will I okay, how do I okay, so teacher a column in box in rotated array Baroni something like is, right? Okay, so to get a column, we can't do this because column is separate, right? So we do integer column equals to 0 and column must be less than rotated bracket 0 dot length and column plus plus, right? Then we do for integer row equals to 0, row must be less than rotated dot length row plus plus, and then we have character current equals to rotated bracket row and column. Column is column, right? Yes. For yes. But here, what do we want to do? Row equals to m and n less than equal to m, row equals to n minus 1 and row must be greater than 0. Minus minus, right? If I'm correct, row is n minus 1, row must be greater than equal to 0 and row minus minus. Okay. So what do we do? So what's happening is, so right now, let's say I have a row 1, 2, 3, 4. I have an obstacle here. Okay, I have a stone here. This is empty, right? This is empty. So right now I'm looping from down to up. So if it's empty, or while so so now after this logic should be like if like while we don't see an obstacle, move down. So I keep a landing row here, right? So what's happening here is I keep a landing row equals to where it will land if it's empty. Landing row comes to if our row and column is landing row is rotated of row. Suppose column looks right. I have empty stone, obstacle. Stone found already, so no then. So at a landing row, right? So what's happening is if what is star is stationary obstacle. If at that index we have obstacle, our landing row becomes previous to obstacle. Okay. If okay, so we will initialize. Okay, in picture landing row equals to and -1, right? So if we find an obstacle, we move the landing -1. So if rotated of row bracket column equal to which character equal to obstacle, then landing row equals to row number is 1, right? If there is a stone, if there is an empty space next, right? Else if there is a stone, okay, else if rotated of row equal to stone, right? We check if I have a stone, if I check if land if landing row if equal to row, if landing row is not if row is not equal to landing row, so if landing row if row is not equal to landing row, then rotated of landing row bracket column equals to a stone. We put the stone there, right? And rotated of row and column equal to empty space, right? Then we do landing row minus, we move minus. Okay. And return rotated off and save the C. Okay. Is my internet not working? It's fine. Okay. Let me check. Yeah, this is working fine. Is the website down? Or something's wrong. Okay. So first I should return the rotated array. Bro, this is taking too long. Okay, it's saying it's correct. Alright, I'll try to do it later on, but I think this is the correct answer. I think something's wrong with LeetCode right now. I'll see you guys tomorrow.